Hello everyone, and welcome to another session about AI technologies in .NET. So today our AI expert Artur will talk about retrieval-augmented generation pattern, which is my understanding a way of getting more precise, more fine-tuned responses from your AI models. So basically, I'm not an expert here, so that's all that I can say. So Artur, I think the stage is yours, and you can make a start and tell us about this pattern.
Okay. Hello, everyone. My name is Artur, and I'm a senior software engineer at EPAM. Today, I'm going to talk regarding retrieval-augmented generation (RAG). During the presentation, we will go through some concepts, what is a RAG, the benefit of the RAG, the basic solution, and some techniques for improvements of a common solution. And of course, at the end, we will have some demo with different approaches. And let's start with definition. What is RAG? I would say it's like architecture approach to improve the quality and accuracy from the LLM. As well as the LLM will have some expertise in your domain-specific area, because, as you know, LLMs are trained on some synthetic data or some data that out of date, and as a result, the LLM is not able to produce more relevant information regarding your business or regarding up-to-date information. And what changes we have? As I said, LLMs can produce some false information when LLM doesn't have enough information regarding it, or provide some out-of-date information. And based on the data set that LLM was trained, some responses can be from not authoritative sources. And of course, the last challenge related to generating some inaccurate responses and due to terminology confusion. And the benefit of the RAG, it's improved accuracy as well as improved domain knowledge regarding your business. It can help us to reduce some bias and misinformation, dynamic adaptation, because for RAG, we don't need to have some fine-tuning. We send up-to-date information to LLM every time. And the last point related to reduce training costs. As I said, it's not fine-tuning. As a result, we don't need to make any preparation for it, and as a result, the cost is cheaper with RAG rather than fine-tuning. And here is the basic solution of the RAG. Let's imagine we have a question from the user to complete some actions in our application and receive some up-to-date information regarding our business. And the basic solution contains two main parts. The first, it's retriever. The main responsibility of the retriever is to generate embedding based on the user question and try to find similar vectors in the vector database. As soon as some data is received from the database, we send this data to LLM as the context. And here I'm going to discuss what types of vectors are supported for us. We have a dense and sparse vectors. Dense vectors, it's a numerical representation of semantic meaning of the text. For instance, queen and king, it's pretty similar vectors because it's often used in the same context. And in the graph for LLM, the points, too close to each other. As a result, the vector are similar. But we have some opposite vectors like sparse. It's numerical representation of text syntax. As a result, the queen and king are not similar because it's two different words. But for instance, sun and sunny, yeah, they will be pretty similar. Also, we have some techniques, yeah, to improve the common solution, because the common solution, if you take a look at the common solution, we have some retriever. We try to create embeddings based on some LLM model, and put all information from the vector database based on the user question to LLM. But unfortunately, in some cases, this solution won't work, and we need some improvements. We can make some improvements based on the multi-query approach, reg fusion, hypothetical documents, routing, query construction, ranking, fine-tuning, etc. Today, I'm going to show the first group of the approach. It's, these groups doesn't have a lot of effort for implementation. We don't need to spend a lot of time. We don't spend a lot of money to implement these approaches. Let's start with multi-query approach.
Arthur, here is one question from
yes.
the audience. So could we use different models for embeddings instead of the same model with LLM?
Yeah, of course. It's what we should do, because for receiving...
we not only could, but we should, okay.
Yeah, okay. We should, because some models are, I would say they were trained, yeah, to produce some vector representation, but other are trained to receive, to generate a text and to receive some information based on our context. And multi-query approach. One block was added to our common solution. We have a block, and the name is similar question generator. The main responsibility is to create pretty similar questions based on the user question. Looks like, for instance, we have a question and we can create a prompt. Please generate 3 similar questions based on the user input, so that we will be able to apply them for vector search. And LLM will generate us 3 similar questions. And now, instead of send 1 question to single retriever, we send 3 questions to 3 different retrievers, and each retriever will do the same thing. Try to receive embedding based on the question, and find similarity by vector. As soon as each retriever receive documents based on the user question, we just put all documents into context for LLM. Of course, you're able to limit the number of documents for retriever, to decrease number of tokens for LLM, or send it in chunk. It's the first approach, like multi-query. As you can see, we don't need a lot of effort to implement, just that additional block to call LLM with appropriate prompt. It's like prompt engineering. And let's go to the next approach, reg fusion approach. It looks pretty similar, but at the end of before sending the data to LLM, we have some ranking model. The main responsibility is to sort the documents that were returned from retriever based on their relative. Like, okay, if one of the document meets in the output from each retriever, it means that this document should be in the top of the context. And as a result, this document is more relevant to answer the initial user question. Again, yeah, we have a similar question generator. We generate some similar questions, send it to retriever. Retriever try to find the similar documents in the vector database. And after we send all these documents to ranking module, and based on the sum functions, for instance, here I add as a name like reciprocal ranked fusion function, but you are able to choose any of them. And we, as soon as a sorted of documents made, we send all these documents to LLM. Again, we can make a limit of documents for sending to LLM. As a result, yeah, at the top we will see more relevant and accurate data to LLM. Okay, and
Yeah, Arthur,
sorry.
one question from my side. So it seems like instead of a single or two calls, there will be 6 calls in that approach, right, to the LLM, which makes the whole process more expensive, right? So that's a disadvantage, obviously. Okay.
In some cases, yes, we can say it's a disadvantage, but it can improve the document. It can improve the quality of document that will be generated, because now we send, for instance, as you said, 6 calls or 3 calls, but in this case we can collect documents from each retriever and sort only documents that are faced in each retriever, in each output from the retriever. It can be more expensive, but it can improve the quality.
But significantly more precise. Okay.
Yes.
So another question, I'm not sure what does it mean, so I'll just read it. Which RRF usually used BM25? Not sure that has no sense for me. Maybe you are Arthur understands.
As I said, for instance, I put here the name of the function, one of them, but BM25, it's like, I would say, text-based search algorithm. It's a pretty good algorithm, but it used in conjunction of dense search and BM25. We can use, and at the end we should have some ranking fusion approach. But BM25 is algorithm on the search based on the text. Yeah, okay. I'm going to show one of the approach for hybrid search, but I'm going to use sparse vector rather than BM25 algorithm, because BM25 algorithm is so popular for this purpose, but I believe the sparse vector it's pretty interesting approach. Yeah. Next approach related to improving the quality of data, it's hypothetical document approach. And here, instead of generating some similar questions from the user original question, we are going to generate hypothetical document. And again, we can create a prompt to LLM to generate some hypothetical document based on the question that will contain, for instance, 3 paragraphs. And as soon as we return this document, now the retrieval will work with hypothetical document rather than the user original question. And based on this document, we will try to return embeddings, first of all, for this hypothetical document, and try to find similarity by the vectors that were generated for this hypothetical document. As soon as we receive, we send all documents that are similar to the hypothetical document to LLM as a context. Yeah, it's the last approach from my list. I mean, for the presentation, because I said it's the first three approach. It's we can group in one group, yeah, like query transformation group. But if you want more expensive, or if this group doesn't meet the quality of the response for you, you should add additional approach, like for instance routing. Routing, it's pretty similar to function calling feature that we discussed on the last event related to AI, where you can route the user question to appropriate data source. For instance, if you have three knowledge base stores like SQL, MongoDB, and some vector database, you're able to route the user question to appropriate one and receive the information from this particular store rather than collect from all of them. And of course, fine-tuning, I believe it's more expensive, the approach. In this case, you need to make a lot of effort, prepare some data sets and some tests and checks for your response, for the responses from LLM. And if it's not, I mean, if so basic approach, it's not enough for you, of course, you should try to apply more solutions, more approaches. Okay, and let's go to the demo. Okay, let's start.
That's my favorite part.
Yeah. Today I'm going to use the same solutions that we used previously. It's the eShop application where the user is able to find some products from the catalog, add them to the cart, make a purchase, and create an order. We use two databases. One, it's SQL database, MS SQL Server, to store products to store products, and the second, it's vector database. I choose Qdrant. It is written in Rust. It's pretty fast, and it supports sparse vector search as well. And we have two APIs. The first one related to generating sparse vector. It's written on Python, and the second API, the main API that contains all controllers that we need to achieve user action, like add items to the cart, make a purchase, find appropriate products from the catalog, etc. And we have a UI. It's written on Blazor. And for orchestrating AI, yeah, for managing functions instead of managing on our side, we use semantic kernel.
Yeah, Arthur,
yes,
there is an ask from audience to zoom in a little bit the IDE. Yeah, okay, so you can zoom in the code, but probably you can't zoom in Solution Explorer. That's a disadvantage of Visual Studio, I think. Anyway, yeah.
But we can offer our audience to zoom in their personal screens.
Okay.
Because here in the very bottom of the screen, near the name of Artur, there are tabs.
Yeah.
You can just press
plus minus. Yeah.
Yep.
Okay.
Okay. And we add some plugin to the kernel where we described supported functions in our application, like search products, create cart, add product to the cart, create order, and purchase order. And yeah, okay. And now I'm going to show, we have a catalog with the products, and we have an order page where we can see that some orders were paid, some unpaid, based on the user decision. And here I'm going to compare the same questions to the LLM, but with different approaches. Like the first approach, it's without reg. In some cases, it's reg because we send all data, yes, that was received from the catalog to LLM, but unfortunately, it's unsorted and structured. In some cases, it's structured because I choose CSV format, yeah, to it. But let's start. Let's start with a common chat without any. Okay. Let's start.
No computers available this time, right?
Yes. Okay.
We have something.
Yeah, we have something, but as you can see, it's not computer. Yeah, for instance.
Mouse, right.
Yeah, in some cases, I would say, oh yeah, this particular product is present in our catalog, but in some cases, since we send unstructured data or it's so huge amount of data, the LLM can generate based on all these names, so new products that don't exist in our catalog. As a result, we can see some bias or hallucinations, yeah, from the LLM. But okay, let's do the same, but with hypothetical document approach. I'm going as soon as I show some UI stuff, yeah, I'm going to back to the code to show what we have in the code, like how to populate the data in a vector database, etc. Okay, next question. It will be Tom. Okay, as you can see, now we have like 3 computers. Of course, it's not sorted by price because I believe we need to add some note regarding the LLM. Yeah, we send the data to LLM, but LLM there are not like calculator or a sort algorithm. Yeah, they just receive some data and try to generate another text based on the input questions. It's why some items can be unsorted, etc. But as you can see here, we receive more relevant information rather than the common chat. And let's maybe try to find. Yeah, we have this computer and other computers in our catalog. And I believe they are, yeah, it's the first 3 cheapest computers, but it's not unsorted. Okay, maybe let's try to find some computers with specific color. Now we in the hypothetical document approach. And here, as you can see, we received 2 computers. Let's again check. I believe this first one was already chosen. Yeah, it's lavender. Yeah, and let's find another one. Yeah, it's also lavender, as you can see. Let's try to ask the same question for common chat. No, yeah, it's
one more time. Yeah, right.
It cannot answer so unpredictable question. Okay, we receive some product, but looks like it's not correct.
It's not a computer at all.
Yeah, it's not computer. It's not lavender color, and
okay.
Yeah.
So this like very nice illustration that like if you get out of the box the model and try to use it without any additional techniques, you will not get a good quality product at all. You will just get a useless chat assistance or something like that. So
yes,
definitely it's a powerful tool, but you need some techniques like what you are just trying to show us. This is the only way how you can use this tool and get a really good quality responses. Nice.
Yeah, I agree with you because okay, we have LLM, but LLM it doesn't aware regarding our business. It doesn't aware regarding sorting, calculating, etc. It just tried to generate text based on the semantic meaning, etc. But in some cases, we are able to help, the LLM to generate more predictable responses. Okay.
Yeah, I like this statement that it's not a calculator.
Yes. And okay, now let's go to the code. As I said, now I'm going to show what we need to do. First of all, in the solution, we have a worker to make some stuff for populating of data in vector database. Okay, what we have here, like, first of all, we need to receive all products from the catalog and create a collection in the vector database. As I said, I used Qdrant vector database, and choose what function we are going to use for to find similarity between two vectors. In my case, I choose the cuisine, but you're able to choose from available list of functions. And okay, for each product in the catalog, we are going to create a document. It's, as you can see, pretty simple document for us, like ID, name, description, color, size, price. And since it's the string representation of the document, now we are going to receive embeddings. As I said, we are going to receive dense vector from the LLM and move to the previous question, regarding should we use different models or not. As you can see, for embedding, we use specific model that was provided by OpenAI, ADA002. And we receive array of floats numbers. It's a vector. And as soon as we receive, we just create a particular point struct. It's related to Qdrant, but for your specific vector database, you will have another struct, and just save this data in the database. Yeah, and that's all. And that's all that we need to have a text representation and vector representation of this text regarding your product. One note regarding the vector database, Postgres enable us to use to store vector database along with your data, because vector data type is supported in Postgres. As a result, you don't need to have dedicated vector database. You can use Postgres for your purpose. And you are able to do any similarity search based on the PG vector library. Okay, here we just populate that data with vectors, and let's go to the API search, API service, and here we have dense search service. as a result, it's pretty, as you can see, it's pretty similar approach, because we just received product name and color that was captured from the user questions. It was configured by me. I mean, these particular functions that are supported in our application. If you, again, if you don't know what is the function calling, feel free to watch our record regarding the previous event. And as soon as we receive the embedding based on this user question, we try to find a vector in the database and return all documents from the database. What we have here, like embeddings, yeah, because here we are going to create a hypothetical document. If you take a look here, we don't have any calls to LLM. Yeah, because on diagrams that I showed in presentation, you can use this approach, like, okay, please create the hypothetical document for me. But since I know the structure of the document, I believe it's redundant, yeah, to call LLM, and we just need to create a pretty similar document. Yeah, and that's all. And it's related to hypothetical document, but also, as I said, we have a different type of vectors like sparse and dense vectors, and we are able to apply the hybrid search. In this case, we need to receive, first of all, embeddings. It's dense vector and sparse vector related to user question. As soon as we receive, we need to find documents related to dense and sparse vectors. And as soon as we receive, we need to apply RegFusion mixing with the function that I mentioned based on your solution. Okay, if we face some document in each response from related to dense and sparse vectors, we need to put this document on the top in the context. As a result, we will have in the top more relevant documents. Yeah, and that's all regarding the code. It looks pretty similar, simple. Sorry, yeah, and you don't need to spend a lot of time maybe for implementing this. But for hybrid search, I believe it's so good approach because we search documents based on the semantic meaning, but at the same time, we will search some documents based on the syntaxes, like, and after that we group that and we'll receive more accurate and relevant information for us. Yeah, I believe yeah, that's all from my side regarding the demo. If you want, I can show something more simpler if you're interested.
Yeah, Artur, there was a question. Will you push this code to the GitHub repository and share a link? You've already done that, right?
Yeah, yes, I've already pushed it, but let me, yeah, I will copy and paste in the chat this one. Yeah. And here are some links to investigate, for instance, what is qdrant, yeah, and what is vector database, like some different approach for RegFusion. Maybe it's related to the question related BM25. And here in this article, you are able to investigate different approaches for RegFusion. And yeah,
right.
I believe,
yeah, so
that's all.
Folks from the audience, would you like Artur to show something else? If so, please put your questions into the chat, or we can unmute if you wish. So there is a question: which materials you, Artur, would suggest for learning this topic deeper? Do we have any courses at EPAM? And I think we have on the call a person from .NET Competency Center. So I think we have Evgen. I think, Evgen, you can answer on that, right? Okay. So your reference to Roman. But I know that the course about REG was launched a couple days ago by .NET Competency Center. So maybe, Evgen, if you're on the call and you can share a link. Okay. So Evgen is not going to share the link, and I will try to search it.
Maybe we can unmute Evgen. Maybe this is the problem. You can just raise your hand, and that will help us to unmute you. So just raise your hand. The settings that we have here. Oh, thank you. Just a moment. Hello, mic, and hello, camera.
Yeah, thanks everyone. We have Roma, who is author of this course, on a call. That's why I was trying to reference to him. I'll share a link in a second. There is a new run which also covers some RAG practical examples for people that want to play with it. So feel free to register. A course is not available worldwide yet. It's available in for EPAM only. And it's kind of Europe and part of Asia for now, and it would be globally available in a few months. You have a link.
Thank you.
All right. Do we have any other questions?
I posted the link to the GitHub, to the solution. Also,
so
it's,
there is
I would say like it's .NET Aspire solution. If you're interested, you can run .NET Aspire to investigate this one.
So there is a comment that some like examples, some code is based on the Python scripts. And can you comment, Arthur, why Python is like a language that you have to learn and if you wanted to dive into AI?
Well, from my perspective, it's because a lot of libraries are written on Python. It's why you should learn in some cases. But as you can see, we're able to achieve some stuff on .NET without any issues. And I choose only one API on Python because unfortunately it's not supported on .NET, and it's why I choose Python to generate sparse vector. But maybe later we will be able to find out the solution on .NET, and this presentation will be on .NET only. Yeah.
Okay, one more from Ruslan. Just wondering, have you conducted any benchmarks around search approaches with larger amount of data? Do you have any tips regarding this topic?
Oh, no. Unfortunately, I haven't had a chance to make any benchmarks. But of course, I believe it's so.
Okay, so what could be the bottlenecks? Where could be the bottlenecks, Arthur, from your perspective?
From my perspective, it's related to creating, first of all, data set for sending to model, and creating some validation checks because we send some data to LLM, and we need to understand was the data is correct or not, and we need to have, I believe, so experienced people to create those type of tests to understand regarding the benchmark, first of all, and the quality of the responses. It's why it's bottleneck, I believe.
So another question, how many documents do you need to put into a vector database to see the improvements?
Regarding the improvements of search, because it's up to you to store as much as possible documents as you want, but Yeah, because vector database store data in vectors, its numerical representation. As a result, the size of the data it's not so large, and I believe it's not so complex to find along this data a specific one. I believe you can choose any number of documents.
Okay. So seems like there are no new questions from the audience, and that means we can wrap up. Oh, sorry, one more from Vyacheslav. You mentioned and well illustrated that LLM itself might be very confusing with the results it provides and suggested to use additional techniques on top of it. Could you provide an example of techniques?
Okay. I believe we showed some hypothetical document, for instance, recfusion, query transformation, like creating additional questions to LM, and of course at the end, if you didn't receive appropriate result from LM, you can choose fine tuning.
Basically, what this is what you mentioned during the presentation.
Yes.
Okay. Right. Are these techniques, Vyacheslav, we can unmute you actually. Are these techniques, names of them, kind of standard patterns and any kind of well-known in community?
Yeah, I would say so. If you just type any of them that I mentioned, you will be able to find appropriate materials from the internet.
So basically you showed today the implementation of these patterns in .NET.
Yes.
But this is like a common patterns of, these are the common patterns of working with the AI models.
Yes.
Okay. So 1, 2, 3, and let's try to wrap up. Okay. So Arthur, thank you so much. Is there any way to apply this kind of knowledge of RAG solutions development in EPAM?
Why not? You're able to apply this knowledge to
basically,
any solutions.
if you have a requirement to add some AI technology to your solution, you definitely should try to introduce some of these patterns like function calling, reg patterns, because otherwise you will get very useless AI assistant that will not be, and you will get any benefits from AI on the project. So you will get something what Arthur showed, when AI will just provide you irrelevant responses, will invent some, like will provide a sometimes fake data. So
yes.
So basic model usage is not a way to build a high quality product. So Yuri, I think, so Evgen, maybe we can, or someone from the audience, maybe, I know there are a lot of initiatives at EPAM on AI topics, and Yuri, if you are really interested in that, I think your RM or maybe someone from audience can connect you with the proper people. So my understanding, you, Arthur, is mostly investigating that topic on your own. I think you just have some enthusiasm, right?
Yes, but I participated in some POCs, as Evgen Mordek mentioned that in EPAM we have some POCs to apply AI to in EPAM. Yeah.
Okay, cool. All right. Let's just wait one more second and then try to wrap up the call.
Let's
one more
count
time.
to 10. Maybe 1, 2, 3 is not enough.
Okay. All right. Yeah, I think this time that's it. Thank you so much, Arthur, for your great presentation. I hope we will proceed diving into AI with you. It's a really nice journey, and you're a very nice person, a very nice guide in it.
Thank you.
And for the audience, thanks for attending the session. Bye bye, and have a great rest of your day and a lovely weekend.
Yeah, have a good day. Bye.
Thank you. Bye.